Let me introduce myself. I'm András Kovács from NIF Hungary, the Hungarian ENRAN. And I'd like to welcome you in this session and thank you very much for coming. About collaboration. As it was published in the preliminary program, it's going to be about content portals. I have to disappoint you. It's the program a little bit changed because one of the lecturers became the victim of the financial crisis, so we had to find a substitution. But still, I'm pretty much sure that you're going to hear about important results and findings. So the first lecture is about a fantastically interesting service made at Switch, which is a video content portal. And Fabio will be giving this presentation to you. I don't think that we need to, I need to introduce Fabio to you because he has been around for 4 years or 5 years now, and he was also co-chair of one of the Terran task forces. So please, Fabio.
Thank you, Andreas, for the nice introduction. My name is Fabio Reina, and obviously I'm working for Switch. Today, the microphone. Sorry, it's on. It's fine. So today we are going to talk about the wonderful world of the lectures hall, like this one, and we are going to talk about video and cameras, actually about this installed here. If you read the title, I can't imagine about what the talk will be. I'm supposed to be a professor. So, there is still something to learn. So, I was about to say that if you read the title, probably you can't imagine about what the talk will be. Is the microphone fine? And if I had to define what is Switchcast, actually, I don't know either, so I tried to define it with one sentence. And I would say Switchcast is a sophisticated video management system. This is what it is. Can you now imagine what a video management system is? But I'm quite sure you know content management systems. You know learning management. These are all specialized systems. The first one for web pages and content enterprise pages. The second one, LMS, for learning objects. And now we have something new. We have something which is around video and specialized actually for doing video with a high quality. Basically, it's an application or a system that makes able to record lectures, how we make it here, to upload it to a central server. This is the idea, it's a central server, and distribute them through the internet. But it was initially built for lecture recording, but we discovered very soon that actually you can do with this system anything which is about video. So if you have a single little video movie, you can upload it to the server and distribute it and make the use of all these tools to distribute it to the network. This is a quite new service. It was relaunched, I say relaunched, in the autumn 2008 because actually we are working in this area for years now. I started at Switch actually with this project, doing something about, early we called that streaming. It was called streaming. Now we're doing more recording, and streaming is more downloadable. But actually, I was here in 2000, not here, but I was at TNC in 2006 and presented another system which was called Play. Maybe you can remember it. And the way we did it in between, this is actually what I want to show you today. The hosts who have seen the presentation 3 years ago, it was about a tool. It was a tool with a lot of modules to record, doing some synchronization, putting it on the server, a lot of work. And actually, now we don't have a tool. We have a system that covers the whole workflow of such a production. Not a single piece of the production, the whole. So starting from the camera, here we can see it, with software that makes it able to record several video sources, put it on the server, as I said, a central server, use web-based tool to edit these videos, and use also the system for our archiving the videos if you want to do that. So archiving it for a long-term, on a long-term basis, making searchable, and all these tools which are around such a system. Embedding, making it easier for user to embed it in the LMS, in the content management system with some special technologies. And the end of all this workflow is actually the same. It's a content management system, but we believe that we will find this video very soon in learning management system. As example, Moodle, OLED, Blackboard, Ilias, and all the, you name it. Today, it's impossible to cover for me in 20 minutes the whole workflow. What I will do is, actually, the workflow, I've forgotten to say, the workflow is specialized actually also for the whole production and the people who are involved to doing this production. So you start actually very often with audio and video specialists. We can deal with microphones, not like me, and which are specialists with the hardware. They do the recording, then it's uploaded to the server. There, assistant of the professor or students work with the videos, make chapters, edit the tools. So it goes on to the next steps. And then it is made available for consumers on the web pages. And the workflows follow all these steps. Today, for me, it's impossible to cover all the steps. I will focus on just three of these production modules. Starting from the recording. From the very beginning, we said one video source is not enough for recording. We have to cover more. We have to cover actually the whole lecture hall in somehow. So starting from the presentation, this is where the content is. Starting from the audio, because there is the most information, what I'm saying. But also the speakers. Very often, this is very important to know who does it like me. And also for the final product, you will see it at the end. Getting more than just one sources, you will get a much higher, better result. You will see that. And there are many software. You can buy software for recording for about $50, I think. So there is not really something special, but what we do here, apart from the two video sources, is to try to make it as stable as possible. This is the most important thing during the recording. So if it crashes now, the presentation is lost. And I will for sure not come back here and represent just because the recording was crashed. So this is really a critical moment, so it can't crash during this session. So we try to find a mechanism to make it as stable as possible. If you are software engineers, you know it's impossible to do software which doesn't crash. So Windows can do it, even Apple crashes, all software crashes. So you can't avoid crashes, but maybe you can do failover, include failover mechanisms. So if it crashes, you should be able to reconstruct the result. I have to mention, if you are not a video specialist, actually, if a video file crashes and it's not properly closed, the whole recording is lost. So if you have a crash after 2 hours, 2 hours of video sources is lost. You can't recover it because of the byte structures of video encoding. It's very hard to do that. So what we do? Actually, we do little chunks, pieces of video. So closing the video each minute. So after 1 minute, you have a piece of video which is already safe. And doing that all the time. So that makes it that if it crashes, and we have a percentage of 0.05, but that's already too much because you lost something. But if it crashes, you just lose a little piece of video. Losing, in our case, at maximum 1 minute. What we do also, we take the slides in a discrete way. That means you make a snapshot, and once you have the snapshots, it's already saved. So this second part can't crash, actually. And it has also some other advantages. Taking just discrete slides make the amount of data a little bit smaller. So you can also optimize the amount of the data recording. Once you have all these pieces and the presentation is ended, you have the result. With this information, you can reconstruct the whole lectures. It's reconstructed, sent to the server, and we make 2 videos of them. And from then, now you can imagine how it is processed. But this is a crucial element. So from little pieces, we make two video sources. Something we have seen during the years is actually that in the production, you start someone to record. The staff is instructed to do it maybe 5 minutes in advance. They forget it to stop it after the presentation. And you have always some videos which you don't want to have in your final result. And to achieve a better product with a presentation or a video where the presenter say hello together, and it really starts in this moment, you need to provide some kind of tools, and actually it's an editing tool what we provide. There are also editing tools around Final Cut and so on, but they are so complicated. So if you are not instructed to do that, if you have not a big experience in the area of cutting, you will not be able to do that. And this tool is actually done for assistants for students, which are maybe biologists or other kinds and have no idea about videos. And we made it so simple as possible. So dragging a little bit some in and out points. And we made it also possible, a very typical situation we noticed is the break. So if you change from one session to the other, in this case, we will see that here, or in a lecture, the break you have in all lectures, you want to cut it away. So it's not just the and, the in and the out, it's actually a sequence of in, out, in, out. And we have seen that students, assistants could work with these tools without a lot of explanation. They made it by their own. You can see also some other, in these tools we provide chapters also. You can set chapters manually or correct the one which was created automatically. You can do some other correction, but they are not so important. These are just there if you want to achieve an even better product. And there is one important button, this is the publish button, where we think that even if the whole process is automated, you don't have to do a lot of things, there should be one manual interaction. Someone looks the video, take care that the quality is there you expect, and manually interact the publish. So there is just one manual interaction which is really needed for a final result. If you go to the embedding, once you have the videos, you usually, all of you have done that, you have to include it in your web page or in your LMS or wherever. So what you do is mechanism. A lot of you knows the typical mechanism. You go, for example, to YouTube. Then there is that section. You can copy paste a snippet of code and include it to your own page. But we went even a little bit farther. So what we include is not just the video and the player. We include a lot of information. We will see that by the result. So with this little line, if you want to embed our results in your web page, you just need one line. And with one line, you can achieve this whole result. Not just a player, not just a YouTube player. You get the whole information from your system about RSS feeds. You see that in the upper corner. Preview images of your video made automatically for you. Metadata information, names, speakers, and so on. Okay. Sorry. Okay. So by adding this single line, actually, which is a piece of JavaScript code, intelligent JavaScript code, you include the whole information you need. As the metadata information about name and subname and so on, the links to the formats you have chosen or configured. So if there is no iPod version, there will be not an iPod link. If the iPod is broken or so on, it's not shown. So you really, the system show in this automatic page what's included. I've prepared here some of the use cases we have now on the system. We cover actually, most typical are lectures. Oh, I'm sorry, I have no longer a microphone. It's good to hold the desk. Yeah, the most cases are lectures. So we go in the lectures room, and a lot of lectures are recording now in Switzerland. But we cover also conferences, as any universities in Europe and worldwide has on a regular basis conferences, important people that come to a university and can be recorded. What we do also is we can even record with these systems. I said it's a generic system for video, and we cover also video conferencing. So coming from this world. And we see here an example of an MCU session, if you know that, and it was a special event about Google, for example. But also other screen recording. We see here a microscopical application where someone recorded the electronical microscope to the screen and provided it a session. Training session, if you want to instruct someone about something, there is no better means to show a little video showing how to be safe from virus, bugs, and so on. It's actually the German title. And also celebrities and so on. So all the happenings and events which are held in a university are worth to be recorded. So let me change, if I can do that. I've prepared a little demonstration, a little page to show you how it is in real life. So this is a simple page with a lot of examples. Some of them you have seen that in the PowerPoint presentation. And I know that you are technical-oriented people. You should know a little bit about HTML. If someone helped me to find the source code, ver código de fuente. I know a little bit Spanish. So you see actually what I explained. So these single line here, they are made in single line because they are single examples. Construct the whole page for you. So I try to reload, and you will see actually how it is constructed for you. And players and all you need, plugins and so, no plugins no, but players and all you need are already provided by this JavaScript. If you go here and take a look at the results, I didn't test it, but I hope that the quality, the internet connection is good at the network conference. And we see
Einen wunderschönen guten Morgen, meine Damen und Herren.
The two videos.
Ich darf Sie sehr herzlich begrüßen.
Oh, yes, this is
Zur heutigen Vorlesung Corporate Finance.
sound. Okay. It works. Sound is there. I'm sorry, actually, that the ratio is not the best here. But you can see some interaction, some presets. You can choose some presets if you want to focus on one, maybe on the presentation. You can do that even manually if you want to see the speaker. Everything provided by the system. Nothing interaction. Special about this is also that we cover smart boards. So this is very typical nowadays that the teachers don't do boring PowerPoint presentation as I did, but use actually smart boards to present their formula and mathematics and whatever. And we see here the result. He's using Windows. Everything is synchronized for you.
Dann ergibt sich aus der
Maybe we can see here at this, I like these examples very well. This is a microscopical application. I go full screen if I can here. Let's go full screen. So we see here, he's showing and explaining what he's doing, using also a smartboard. We will see it right now. Okay. So, obviously, all of you know that we have different formats. So a high-resolution QuickTime format, which can be used in iTunes, for example, or this modern iPod version. We can see it. I will show it in this case. Oh no, there is QuickTime. With a picture-to-picture approach, so we still stay on the point that we need both sources. And you see, to see just the speakers moving a little bit around for a result which is for several minutes makes the result much, much better than having just a boring slide which doesn't move. And what can I show you else? Actually, this one. And this is actually, no, here, Terena. And this is actually the typical way you use if you use our system. So you have a content portal like the Terena webpage, and you have the videos which are on our system, and the things we did as we did this workshop was send this single line to the webmaster. Maybe if you are interested, you can try to find it here in this code. And with this single line, the whole workshop we held at Switch was covered. I didn't show you who knows Peter. Maybe they can show a little thing, a little more. Is Peter here? We see here also something more, so these chapters, this is the first time we see that. And also, you can do it this way.
I'm also very happy to see that there is a number of participants from universities, not just
Terena task forces.
So I think it's useful to have a short introduction
so on.
on Terena first.
And you can click actually and it jumps there.
Requirements.
Everything provided automatically by the
some
system. No human interaction to create these snapshots. Everything is made.
Like to highlight some basic
also, another features we think which is very useful is the fact that you can refer to a point in the timeline. So go there at this minute, you will find the information. Also, everything provided by the system. I will come to a conclusion. Here, I think. As you can see, it's a system which was developed now for years. We started really 3-4 years ago, and which is now really stable. And you have heard it. Stability is in video production the most important thing. It's scalable. That means that you can cover a lot of recordings. We are doing several hundreds per week now in Switzerland. It's something which is growing. It's usable, so very simple, made for the users, for the students. So not about technology, not about codecs. The user can't choose a codec in our system. So there is no choose about MPEG-4 or H2 or Flash. The system decides for him. For the user, it's just a matter of contents, chapters, titles. And it's integrable in your system, as you have seen in content management system and especially in learning management system. It's built on a long experience. So really we have done so many mistakes during these years, and now I think we know how to build such a system. But the most important thing is that it's actually made based on the requirements, the feedback users have gave us over the years. So it's not just a system, a technical system which was provided by Andren for universities. It's a system which all 6 months asks the users, the end users, and we have here someone from Switzerland, and they provide feedback. We think that this button has to be red, otherwise we can't understand the system. And if we think the same thing, the button is made red after 6 months. So this is really a system which was adapted to the user needs over the years. And I think you have heard many presentations about video management systems. I can assure you this one is the one which really works and which is stable and which is in production now for a month. Thank you for your interest.
Okay, Fabio, thank you very much for this very nice presentation. This is obviously a very nice and usable system. And thank you for the excellent timing. Now questions?
Thank you.
To the desk.
I think I'm the first to ask this question. Do you share this code also, so that other NRNs can put up their services?
Could you repeat the questions? I'm sorry.
Is this software available for other providers, for NRNs, universities?
This is a good question. No.
Is that so simple, the answer?
Yeah, it was discussed for a long time, yes. Should we make it open for others and so on? And this discussion started actually at the last workshop. And for the moment, we can just say that no, it's not available. Sorry for that.
Can I ask, how have you built in security anywhere in this?
Security aspects, kind of secure movies or like this, or security in terms of...
access and authorization.
Access and authorization. Yes, yeah. Obviously, I've forgotten that because everything we made at Switch, and we have it here, the project manager, is made by AAI. So everything, any application we do is shibbolized. So also this application is shibbolized and provided for and make available for universities with the means. So each universities have their, and each user have the account made automatically by shibboleth means. Just this security, or also security about access? Access is also protected by downloadable. It works very well by shibboleth, so you can choose several levels of security. And because we try to make it simple, so you can choose about your organization, the federation, so all Swiss universities, and public for the rest of the world. I think the next development will go in the direction where group management, I think this is the new approaches from Widerwall, which is going, so provide group access to resources will be included in. We didn't make it on the video management system because we think that this is an issue of middleware and should be solved there. So we don't have groups here.
Fabio, question from James from ARNet. We have a streaming media project group set up in Australia that's been looking at lecture capture for the last 6 months. We've been looking at Echo 360 media site and a couple of homebrew solutions, including one from Flinders University. Most of them have issues related either to support and the overhead of support, or they're related to licensing and the costs to scale this up. My question, though, is more around getting the lecturers comfortable to use this technology, and I'd like to get your perspective on how you've managed to get users and lecturers to take to this technology.
Yeah. This is actually an issue which is at the universities. We are at NRENs. We're a little bit on the back end, on the back side, but we know the issues at the universities. The way to go there is to provide it more automatically so that really lecturers can come in and it can just start to do their lecture and it's recorded for him. You have to reach that level of optimization that you can really scale for a big production. It was told to me that, for example, 10 years ago, if a lecturer wanted to have a PowerPoint presentation during his lectures, he had to reserve and announce it to the universities to get the beamer. And this was 10 years ago. And we believe that in 1, 2, maybe 3 years, it will be the same. So at the moment, they have also to reserve a room which is capable to record. And we believe that the recording infrastructures will become like the beamer today. It's just there. And once it's just there, I think it will be just used.
Fabio mentioned in his lecture the Terna has this media management and distribution, let's say, group or workshop, or is it going to be a task force? Who knows? And we also discussed the possibility of a European level content sharing portal where kind of metadata harvesting could be used for getting the metadata from the national archives. So this is also a very interesting idea that could be implemented. And our feeling is that research networks are in a very good position to provide these services like this. And there are a lot of projects also in the US and Europe and Australia as well, where similar services are implemented on the national level. SurfNet has something like that. We also are funding a project in Hungary, and there are a couple of other areas, other projects as well. I also have a question. You have a service which is called Switch Collection. We are going to have a presentation in the next session from Rolf, your colleague, which is about e-learning objects. Is it possible to connect these two different things?
Yes, right. In my presentation, in the workflow, I've shown that actually you can archive things, the videos, and they are made searchable to contents. This is not made directly by the video management system. This is made available by a repository, which is actually Switch Collections, which will be presented next session. So there, in this access portal, you can actually look for content, and you will find the embedded content which is coming from the video management system. I think Rolf will show that in the next session.
Yes, we shouldn't reveal what he's going to say. Okay, thank you very much again.
Thank you.
Okay, our next presenter is Jan Reichert. He's originally from Germany, but he has been many places and studied many places. And he's also founder of a company who's providing a software solution for research publication management. Okay, so please.
Sorry, just where did you store the presentation somewhere on the hard disk, or how do you get access to that? So I think I updated the presentation, so I guess I just updated it today, and then, yes.
So we need to go to... Yeah, let's see. And then you just can...
Okay, yeah. Well, welcome to my presentation. My name is Jan Reichelt. I'm one of the co-founders of Mendeley. And what we do is we want to help researchers manage, share, and discover academic knowledge. Just as a little bit of background, who we are right now 15 researchers from a couple of European universities, and we are backed by co-founders and former executives of Skype, Warner Music Group, and Last.fm. So the point where we're coming from is that we think research is inherently social. So for example, take the quote from Newton, standing on the shoulders of giants, but the tools which are out there are lacking in their social aspects right now. So in order to explain a little bit what Mendeley is, we take an analogy of a very successful Web 2.0 business model, Last.fm. I'm not sure who is familiar with this solution or this Web 2.0 service. So what Last.fm essentially does is you have, as a user, you have your own computer, and you install a small software called the Audio Scrobbler on your computer. And then what you just do is you just listen to your favorite music tracks, MP3 files on your hard disk, and Last.fm listens to what you're listening to. It tracks basically your taste. And based on that, it aggregates and builds your own music profile, and by that builds the world's biggest open music database based on the music tastes of all the users of Last.fm. So if you compare music and research, what we think is it would be great if there was a tool which was able to connect basically research libraries, researchers, papers, and disciplines in the way that Last.fm was able to connect music libraries, artists, songs, and genres by a social tool like Last.fm, and that's what we try to do for research. In order to achieve that, we have developed basically two services which form Mendeley. One is end-user desktop software called Mendeley Desktop, and the other part is Mendeley Web. Mendeley Desktop is basically a standalone reference management software, and however, it offers a couple of features that are not there yet so far for end users. So for example, if you can just drag and drop a bunch of research papers and drop them into your Mendeley Desktop software, and it will automatically try to extract the metadata from PDF documents so that you don't have to type in the metadata like the title, the journal, the author, and so on. Obviously, sometimes it works better with some journals than with others, but we are on a good way there. It extracts the full text of the document so that you can then full text search all your research papers. And it also tries to extract the references in the end of each research paper. As I said, you can then full text search your documents, you can tag them, you can create bibliographies in Microsoft Word and OpenOffice. And what you can also do is you can create shared groups and basically drag and drop PDF research papers in there and share them with your colleagues and let colleagues know what you're reading, and that they should have a look at that at a certain set of research papers as well. And you can back up your library and sync it to Mendeley Web, and then sync it down maybe, for example, you from your workplace, and then when you work at home, you just have seamless access. As I said, online backup and online access of your research library. So no matter where you are, it's a cross-platform software. Whether you have a Mac at work and a PC at home, you can access it online via the web. So we say there shouldn't be any barrier to access to what you're actually researching on. You can then also import references from sources like Google Scholar or PubMed or Archive or a number of other databases, which and the number of databases we support is currently continuously growing. And you can import these references into your online library as well. And then that's the most interesting thing, I guess, is we can, based on that, aggregate anonymously usage statistics. So for example, we can tell how many people are reading a certain paper. And similar to Last.fm, can then say, this is the most read author in business administration for the last year, or this is the most popular publication in biological science, or this is an up-and-coming topic in social science since the last 7 days. We are also working on recommendations for research papers. So if you imagine you as a user, you have a certain set of research papers in your libraries, and there might be some other researchers out there in the world you don't know of, and he has a similar set of research papers, then you can, by collaborative filtering, recommend additional articles to each of these researchers, and if they like, you can also connect them with each other. So we basically started development roughly 2 years ago, and since 5 months we have a public beta, which is now in version 0.6. And well, we just gave it out to the public, to the research community, and we're quite happy to say that the largest user bases right now are based at MIT and Stanford. In Europe, that's Edinburgh, Cambridge, and well, in Germany, Cologne and Aachen. So we see a quite good adoption of Mendeley right now, and we can also say that our database of articles that have been added by users via Mendeley Desktop has been growing tremendously. So if we continue to grow that fast, we'll run into serious scaling problems with our servers, and we're trying to ramp up our technology there. So to give you a little insight, well, you can all sign up if you like, but for those people who haven't signed up, these are the statistics. That's what the statistics look like. For example, in business administration, I did an excerpt there, screenshot there, because my field is business administration. You can basically see most read articles in business administration would be building theories from case study research. Obviously, the numbers are still a little bit small, but because business administration, there are not so many users yet as compared to computer science and biological science. But if you just imagine the numbers will grow, then these numbers will also become more significant. Same is with up-and-coming articles in business administration. You can see what are the articles that have been added during the last 7 days, for example, and the further we go down the road, the more detailed statistics we can obviously get. Similar, for example, most read publications overall, Science and Nature, obviously. Most read publication outlets in business administration would be management science, and yeah, some other statistics as well. Apart from general statistics, you can also see statistics about your own library. So you can basically see the history of how many articles you added to your library, and we are working on time windows so that you can scroll back in time and see when you added what and how the usage changed. And that gives you quite a good insight into what your library actually looks like. So if you imagine you have 500 articles in your research library, these statistics can be quite helpful. And then if you go to my publication stats, it actually tells you how you compare to your peers. This is just an example. So if you say your own publications, in 2005 and 2008, you did one publication per year. As a PhD student or even as a professional researcher, you don't know if that's good or if that's bad. But if you compare yourself to your peers, then obviously you can get more insights into that. And as you can see here, one publication in 2005 and one in 2008 is obviously not as good as the average. What is our adoption like? So how Mendeley is starting to influence science? Scientific careers like jobs, tenure, grant funding, and prestige usually depend on the impact factor. And the impact factor in turn depends on citations. So the problem with citations obviously is it takes a long time to appear. So some researcher publishes a paper that needs to go through the peer review process. That takes a year, and then it's being published, and you as a researcher want to pick that up as well, then you have to go through a peer review process as well. So there's a huge time lag. And additionally, the information about the impact factor is quite expensive. It's a fairly monopolized market where all the information is aggregated by Thomson Reuters. What happened a couple of weeks ago, there was a ranking in Mendeley where you can see that Public Library of Science, which you can see here, went up to number 5 in our statistics based on 172,000 research papers tracked. And the interesting thing there is that Public Library of Science is an open access journal. So the editor of Public Library of Science twittered about it and said, well, it's Public Library of Science 1 is now at number 5 ranking of most read biological science journals at Mendeley, and he was obviously quite happy about that. And in turn, there was a huge discussion on FriendFeed about what these real-time impact factors or real-time article-level metrics would mean to science. So we see that there are people taking these statistics seriously, and people are discussing how could that be additional information to the existing measures of quality and impact. So as I said, Mendeley can provide usage-based impact factors of research papers, for example, for audience and reach of research papers. For reading time and repeat readings per papers, we are implementing a PDF reader so that you not only can track how often a paper has been downloaded and how often it is being stored in a personal library, but actually how often or how long it has been read for, or how long it has been, or how often it has been annotated, how often it has been shared. So a very detailed article level metrics. It's similar then to quality ranking and post-publication peer review, and all this in real time, available by academic discipline, geographic region, academic status, and so forth. So what are we planning? What's coming ahead? We have a forum where all the users usually engage with what we are doing right now. It's a feedback forum where people say what they would like to see in the product. We are usually driven by end users, and end user focus, because we started this because we were dissatisfied with the current solutions as PhD students. And as you can see, for example, one of the most requested features obviously is to improve the quality of automatic metadata extraction, because that's obviously a big time saver, but it's also obviously the most tricky thing to do for us. Our view of the world, however, with Mendeley is that we are starting with reference and PDF management. That's what our tool can provide already. You can view your PDF in the next version. You can mark up, you can annotate both on Mendeley Desktop and on Mendeley Web. And we want to support Open URL and SFX. So this is what the new version will look like. You have an integrated PDF viewer in there where you can make notes. If you do a full text search, on the upper right corner, you will see within the PDF document where the word is located and it's being highlighted. You can create sticky notes, you can highlight stuff, so it's all the productivity tools a researcher needs in his daily work of research. The next step is what we are already offering is Word and OpenOffice integration. It's not yet fully available for all platforms, but that's something we're working on so that you actually can create your research papers as an author. And we're also working on a LaTeX integration. Then the next step will be collaboration. Right now, you already have shared groups in Mendeley Desktop where you can share research documents with your lab mates and colleagues of your department. You can create a shared group, invite up to 10 people there, and basically maintain or create a shared collection of research papers. We will add group and lab management functionalities so that people can actually comment on research papers, that you can create a discussion based on a research paper. You can make parts of your library public. Say you want to provide a list of references to, let's say, your students, then you would be able to do so. We also have set up already a sync feature with Site You Like. So if you have a Site You Like library, you can now sync your library with Mendeley. We're working on a sync feature with Zotero and as well to Collab. And this is obviously the ultimate goal, recommendations and well, full text search and related articles and statistics queries, but that's obviously depending on how fast we are growing in terms of user size, but I'm quite positive about that. So since we are a startup and we have some investors, I will just give you some insights into how we see the market. There are 145 million academic and corporate researchers and students and consultants out there. And the total market size for the whole market we are targeting is about roughly 90 billion euros. And our business model will look like that we'll, within the next 6 months, introduce premium features. So if you would like to get very detailed statistics about certain paper, let's say you want to see what is the readership like for a certain paper, you see it's, okay, 70 people have read it, but now you want to see, are these 70 students or 70 PhD students or 70 professors, which is obviously, you know, gives you different information, then you would have to sign up for a premium fee. Premium subscription. Or if you want to have more upload space to synchronize your papers within Mendeley Web, then you would, or you can sign up to premium subscription. As said, we're working on the recommendations feature, so depending on how detailed you want your recommendations, say based on a selection of papers or on your whole library, that's also something we're working on. Interestingly enough, we have been approached by a couple of publishers proposing a model, what we call iTunes model for research papers. Because based on the research library of an individual researcher, we can basically tell the person what is the next most interesting research paper to that person. But obviously, the recommendation as such is only half the value. If we could deliver the actual content together with the recommendation, that would be great. But obviously, since we are not the copyright owners or copyright holders, we need to get the publishers on board, and we are discussing with them an iTunes model. And we have been approached by a couple of corporates and institutions whether we would be thinking about offering an institutional version of Mendeley. And yeah, that was a short overview of what we're doing. I hope you like it. And yeah, let me know your questions, and I'm happy to answer them.
Questions?
Thank you for your presentation. As you store a lot of information and a lot of content, could you tell me something about the interfaces you offer for interoperating with local campus systems or something like that?
Yeah, I have to say that we are starting that right now. We first built an end-user product. So we are offering an API, which is not yet publicly available because it's not ready yet, because the data is not yet clean. And we are talking to a couple of research institutions to see how we can integrate Mendeley with the existing infrastructure on campuses. But there's nothing there yet, but we are in discussions with them. I mean, we are out there since 5 or 6 months only, so. But yeah, we know that there's a need, and we are on it.
Other questions?
Hello, Diego Lopez from Redir, Spain, and well, somehow in charge of identity federation activities and all the like. I would say, well, not only in Spain, through Europe as well. Do you have any plan of including federated access here? This is first. And second, we, the community, have been seeking for some service able to resolve document references, taking into account federated identity as well. Do you have any plans about this?
We had some initial discussions about shibboleth, but that hasn't come to a conclusion. We didn't come to a conclusion there yet. So it's, if you have certain ideas how we could do that, because our view is from the end user perspective, and if you have ideas how we could do that, then we can talk later. We are very grateful for any feedback and help we can get there.
You mentioned the huge publisher companies like Scopus and Elsevier. Currently, the model of distribution of research papers looks like there are huge national projects. They spend millions of euros each year to get all the relevant publications that is needed for national science. So what do you think? Are they happy about changing this whole model of distribution? I mean, you mentioned this iTunes-like approach. Mm-hmm. So are they happy about this, or will they be forced to accept this?
Well, I think the current business model of big publishers is based on subscriptions. So they license their content based on subscriptions to institutions or organizations. What we can offer is, on top of that, this pay-per-download model. So, whether this will, cancel out subscriptions or not, I'm not so sure, and probably that's not something we can decide right now, but it offers additional value on top of that. What we know, however, is that many libraries and institutions have become under pressure because of rising subscription fees, and they were forced to cancel subscriptions to content, actually. So the funny thing is that researchers are producing content to which they, in the end, maybe don't get access anymore because the subscriptions have to be canceled. And a system like Mendeley could make available this content via a pay-per-download basis on top of these subscriptions. That's what we believe.
Another question from you.
So, actually, you stated that your business model is delivering extra services, so that we're one of the countries having a very large scientific repository for articles. So actually, putting Mendeley on top of that might just work, as we will not charge anything for providing access to this service, and you would actually probably be happy to do that for us.
I would say so, yes. We are
Interesting.
right now, we are already integrating, or we are collaborating with Public Library of Science in that case, where we deliver back article level statistics to them, and they in turn integrate with us in terms of content. So, you know, that's something where we can create a win-win situation, because they get insights into how their content is being used, you know, and we obviously get audience. So, yeah.
Any more questions? We have still 5 minutes. You can use it. Okay, then thank you very much.
Thanks.
It was an inspiring talk. Our last speaker is Stefan Karapetkov from Polycom. He's the emerging technologies director working in the US. And he's going to present about scalable desktop video.
Thanks for inviting me. Just need to get a microphone. And you know, I need to copy one slide from the other presentation. Let me just show you.
Right.
Let's open the two presentations. Where is the folder for 5, session 5?
5 is right here. Let's click that, and that as well. That was
Yeah. Can you open these two presentations?
this one.
This one and the other one, yeah.
Okay.
In the next one.
Just minimize it, and then
This one here. And from this one, I just need the last slide. The last slide on this presentation. I need to copy this one here. Copy. And put it in the other presentation in this one here. I'll tell you where. Right here, right after this slide.
okay. So click in here and then paste.
Excellent. Excellent. Thank you so much. Okay, so now I need to start it right here. Here we go. Good afternoon, everybody. I would like to thank Terena and Andros personally for inviting me to speak here at this conference. It's always a pleasure being here, and it's a long way from home. I'm based in California, where my company Polycom has its headquarters. But it's always a pleasure being here in Europe and being able to talk about video technology. I have about 20 minutes, 25 minutes, and we'll leave some time for questions. I hope you can hear me well, and I'm not planning to play any video clips, so it's going to be just a slide presentation. When we discussed up front what the topic of the presentation should be, I suggested talking about scalability, because I think scalability is a very important issue for video networks. And the reason is really that with the advances of desktop video, we're seeing an exponential growth of the number of users using video. And it is wonderful to see so many people starting video calls. Unfortunately, there are a couple of bottlenecks in the networks that I would like to identify in this presentation. And I want to make sure that you're aware of these issues, and when you make your architectural decisions and when you decide to roll out video and expand video, you keep that in mind, and if possible, consult me or my colleagues before getting into this business, because rolling out video is not easy from a networking perspective. It is much more difficult than voice. A lot of people make the mistake to think that video over IP is like voice over IP, because it's basically packets in RTP and UDP. And it's not exactly like that. The packets are much bigger, the compression rate is much higher. Losing a packet, a video packet, is much more of a problem than losing a voice packet because of the high compression rate. So you need an advanced mechanisms for forward error correction, and you need to make sure that your architecture is actually scalable and can handle the load. And there are a couple of points in the video network that are prone to failure because they're just overloaded if way too many people join a video call, for example. And all of this is a result of my personal experience using video in different setups. I'm a passionate video user. I have a video system in my office, and I have another video system in my home office. In fact, I have a paper, I wrote a paper about the way I use video from my home for teleworking. It's posted on my blog page, and I'll give you the link to it if you are interested in looking at that and maybe downloading it and seeing some pictures of my home office. So I'm using video on a regular basis, and I'm persuaded that that's the way to go in the future, not just for teleworking, but for general teamwork across continents and across countries. That's the reason I'm able to participate in events like TNC, Internet 2, and other events, because the first contacts I would make over video, or I will start with a face-to-face meeting, and then we'll continue the communication over video. That's a good way to keep in touch with people across long distances. So I think I showed this slide in my previous presentation. It's really to outline our vision for the future, and we call it VC2, or video conferencing next generation, or version 2. And in this particular presentation, I will look at the IT integration components. How do you create a scalable IT integrated video network? How do you address the issue of scale in general? And how do you do that by using open standards? This is how a typical video network looks like. And you have on the top, and I like to use my laser pointer whenever possible, on the top we have the so-called video endpoints, and they can be personal video endpoints like this one here. This is exactly the model that I have in my home, and I'm using it for teleworking. It's excellent all-in-one system with an integrated keypad, so you don't need to have any remote controls or anything. In addition, you just use the keypad, and you can start calls, terminate calls, and manipulate the call. The room-based system, that's the traditional one that most of you probably have somewhere in a conference room, maybe not this last model, maybe a previous version of it. Usually comes in 1 or 2 screens. The left one shows the live communication. The right one is for content sharing. And the soft clients are a new component that's actually creating a lot of trouble, because even though they're relatively small and they don't pump so much traffic as a room-based system, there's so many of them. And if you have maybe 1,000 soft clients and each is pumping 512 kilobit per second, you already have a problem in the network. And that's one of the major reasons people or IT departments are reluctant to roll out video, because they say, what's going to happen if I roll it out and everybody starts placing 1 megabit per second calls? I'm going to run out of bandwidth, and all the other applications are going to stop working. So really the key here is to provide tools to manage the bandwidth and to limit the bandwidth usage for a particular group of users. The video board, the management application I covered in a lot of details in my previous presentation. It is the application that allows you to provision all the elements in the network, do software upgrades of all the elements, also do scheduling and a couple of other functions that are very important. So that's the central component of the video network, the intelligence of the video network. And the management application may or may not have a call control component. In fact, it's a good idea to have the call control component in a separate server for scalability reasons. But for smaller installations, people want to have one single server. So that's where you can combine the call control component, which is a H323 gatekeeper or a SIP proxy, together with all the other applications in this server. The video border proxy is used for, it's not a standard industry name. It's something that we're using within Polycom. It is a box that allows you to traverse firewalls. And firewall traversal is a major issue right now for video. Actually, when you compare the ISDN video, the old-fashioned ISDN video with IP video, you'll find out that even though ISDN had much worse quality, it has one benefit over IP video. It goes across firewall, it doesn't need to cross any firewalls, and you can call anybody who has an ISDN number and do a video call. There are all sets of technical problems with, combining B channels, but for the basic functionality, the ability to call people around the world, ISDN is right now it's more functional than IP. So that's why most of our work is focusing in this area. How do we traverse firewalls? How do we make sure that video goes freely across firewalls? Gateways go to other networks. You can have gateways between H323 and SIP networks. You can have gateways to ISDN. Some of them touch the media, some of them are just signaling, and I'll talk about that. There was a question after the previous session how recording is done. And recording is usually a software. There are 2 ways of doing recording. If you do a software application that runs on a standard server, like this example here, you can record 1 or 2 sessions in high definition, 720p quality, for example. And you can actually stream the recording simultaneously. That is possible on a general purpose processor. However, if you want to do 10 sessions, you want to do 5, 10, 20 sessions simultaneously, if you want to record them all, you need some DSP support for that. So you need a different box that has DSP resources in it. And that's necessary for the high definition component. Standard definition recording is not an issue. It's much easier. It requires approximately a tenth of the processing power to record standard definition call. Content management is another extension of recording. You can take the files from the recording box, put them on a content management server, and do video on demand. Very similar to the presentation from Fabio. Their implementation is software-based. This is also a piece of software, but we sell it as a server with integrated software because of some security constraints in the enterprise environment. They want to make sure that you do not install the software on just any box. They want to have the box certified and tested, and want to make sure that all the ports are closed and there are no security holes in it. So that's the reason why we're selling this as a box, and as opposite to selling it as a software. I think the educational requirement is a little more forgiving with regards to these security issues, but we sell also to banks, we sell to government organizations, and they will never buy just a piece of software that you can install on a general purpose processor. They want to have a box that is certified, and especially in the government environment, it has to go for months of certification before you get the approval and you can start selling to the government organization. You're familiar with these terms, I hope. The directory is usually LDAP accessible. Presence usually uses XMPP or the simple protocol. And the gatekeeper or proxy, again, can be separate for scalability, or it can be combined with a management application. And the media servers, or the conferencing media servers, are basically a pool of DSP resources that transcode. And I will talk about that component. Is that going to move? No, I need to press this key. This is a brief overview of the bandwidth requirements. I think I covered that in the previous presentation. For those of you who did not attend, the current state of the technology, and this diagram is based on H.264 compression, is that standard definition can be compressed at around 512 kilobit per second at a very good quality. High definition at about starting at 1.1 megabit per second, going up to 5 or 6 megabit per second. And the more bandwidth you have, the better quality. And then around 2 megabit per second, you can get 1080p quality. And I already have seen the demos of the next high resolution level after 1080p. And I don't even have an idea after compression how much bandwidth you are going to need, probably around 20, 30 megabits per second to compress that kind of video, because it's an enormous amount of data. The reason I put this, I just added this slide to this presentation because I think it actually makes the story more logical. This is actually all the functionality that you would put in a data center somewhere in the middle. If you don't want to, you can put all the components in the headquarters, for example. But if you have a separate data center somewhere in the middle of the network, you can put all of these components in there. And what do we see here? We see all of the management functionality. This is another component that we refer to as distributed management application. It's something that I will explain in a subsequent slide. It's the way to combine a number of conferencing server into a single pool of resources. Instead of creating a giant MCU or a giant conferencing server, you just take a stack of them, or you distribute them across the network and use this DMA component to manage them all as one single MCU. And then we have call control, directory services, email and calendaring, instant messaging and presence is becoming very important, network management services. These are components that can be provided by Polycom or third parties. In fact, when we go into many organizations, we have the requirement to use existing components to interact with email. For example, some organizations use Microsoft Exchange, and they want to have us integrate with Microsoft Exchange. They may be using Active Directory, and we have to integrate with Active Directory. That component here is what I think about when I talk about IT integration, because these components usually exist when you go into the established company or established organization. You already have something here, so you have to work with what you have. Conferencing servers, that's basically the multi-point conferencing units. recording and streaming, I explained. The video asset management is the additional box that does the video on demand functionality, and the gateways. Now, there's no problem within a single office. Like all of these offices, they have probably 1 gigabit per second Ethernet, or maybe 100 megabit per second Ethernet. It's sufficient for desktop video or any other kind of video. You can run even telepresence systems with multiple screens. There's no problem with that on the local network. Now, the problem is really the access network. These are the access routers here. So when you go for the access networks, that's where the bottleneck is, and that's where people are very concerned about three things: about packet loss, jitter, and latency. And these are the three things that can make or break video, and it's very important. The most important one actually is packet loss, and that's why we focus on implementing forward error recovery mechanisms to make sure that the packets that are lost can be recovered. But we also have mechanisms for combating jitter and latency as well. So the first advice when you start building a network, how to make it scalable, is never to mix the signaling and the media. And that is the architecture that is used by both SIP and H323. Now, that becomes, and it's usually the case, you don't usually get this kind of separation where signaling is separate from media. However, there are situations where you have to mix the media and signaling. For example, when some of the firewall traversal mechanisms require you to go with the media through some server in the network. They're called session border controllers or application layer gateways. And when you have that, this scalability is gone, because you don't have a direct RTP and RTCP stream between the two parties communicating. You have to go for a server somewhere in the network and then go back to the other party. And usually firewalls create this problem. Another component that can create similar problem, and the problem is really transcoding media, is a media gateway. And it's especially difficult to do that when you have a multi-party call going through a conferencing server, and then you have a media gateway going to another network. The reason is that the media gateway adds additional, I would say, 80 milliseconds or 100 milliseconds, depending how good it is, to the end-to-end latency. And if you already have 200 milliseconds latency between this point and this point, adding additional 100 milliseconds results in the quality of a satellite link. And then you have a problem with interactivity. And in different cultures, the impact is different. In Asia Pacific, you may not have enough impact because people tend to wait. When they say something, they tend to wait before the next person starts talking. But in the United States, it's horrible because people are constantly interrupting each other. So this level of interactivity cannot be guaranteed if you have a media gateway here. So the only solution, if you have a media gateway, is to make sure that the audio and video coding used here and here is the same. So then you can basically go through the gateway but do not transcode, because the transcoding is really the component that causes most of the delay. Another way to scale the network is to make sure that it's redundant. And when I talk about network redundancy, it's really video network redundancy. Imagine you have a server and it fails, then you have to have the capability to redirect the calls dynamically to a backup server that has all the information from the database and can continue the call as if nothing happened. And then once the primary server recovers, then you go back to the primary server. So this kind of redundancy is currently not very well understood in the video industry. Polycom is actually the first company to push for that and say, well, instead of trying to create this giant server and try to do a hardware redundancy, let's just make sure that something like this, switching between primary and secondary, is implemented. And that's the much more robust way to do redundancy in the network. It's network-based redundancy. So the old-fashioned way of increasing scalability is basically putting this DSP blade into different chassis. So you have a small chassis with 2 blades, and then you may have something in between, and then you have this chassis with 14 blades. So if you want to have more ports supported and more participants on a conference bridge, you basically put a bigger chassis and put the same blade in the new chassis. Now this is not a bad approach, but scalability breaks at some point. At some point you have to start looking at network scalability, and that's my next slide. We have selected the ATCA architecture, and for people who are familiar with hardware architectures, that's the only standard-based, that's the most modern standard-based carrier-grade architecture available. It's designed for carrier applications, but we see demand for this kind of reliability and failover in the high-end government, banking system, and high-end enterprises. Not sure if education is going to benefit from that. What it gives you is really the failover mechanisms between blades. If one blade fails, the other one takes over. Hot swappability, you can basically remove the blades on the fly. You don't need to shut down the system to do that. So this kind of functionality is very important. It's very efficient cooling. There are several fans in here. And the power supply is also very flexible. You have triple redundant power supply, and you can feed in AC or DC power, depending on what kind of environment you have in the data center. I already mentioned that in my previous presentation. Another way to increase capacity is to remove this restriction here. Instead of saying this bridge is only for 60 standard definition calls, or let's say 40 high definition calls, you can relax this requirement and say any of this can work. Any mix and match can work. So I can have, maybe instead of having 40 high definition calls, I have 20 high definition calls, but then I have another, let's say, 30 standard definition calls, or another 80 SIF calls. So when you allow for this flexibility, your bridge automatically starts supporting much more than in this environment here. So this is another way to increase the capacity. The lower the quality of the call, the more you can support. If you increase the quality, you support less number of participants, but you have the flexibility to dynamically assign the resources. I mentioned the way to manage the resources of the conferencing server dynamically, and that's this distributed management application. It's a unique application that nobody else has, basically. It's because we believe that that's the way to scale. Instead of creating a giant MCU, we can have several relative small MCUs across the network and control them with its DMA server. So when a call comes in, the DMA runs algorithms and finds what is the appropriate server to send this call to. And the routing algorithm can be as sophisticated as you want. It can be just checking of availability. Do I have sufficient resources on this server to run a 20-party conference? Or it may be more sophisticated and look at geography, for example. This server may be in Australia, this one may be in Europe, this may be in the United States. So when a call from Australia comes in and the server knows that 5 of the 6 participants on the call will be from Australia, then it will send it to a server that is in Australia and only one remote participant will connect. So in this case, you are using the bandwidth in the network more efficiently. So this kind, and if the resources here are exhausted, the server can also connect some of the participants here, and create a link, which we call a cascading link between the two, so that we can have these two servers connected. And that's very efficient when you have 5 people in Europe, 5 people in the United States. You don't want to have 5 links going across the ocean. You really, I understand that in the Terena environment, that's probably not an issue, but in most networks it is, when you have 5 links, each 5 megabit per second going across the ocean. We have looked at other ways to scale our system. We have a XMPP-based presence implementation. It's mostly used for our soft clients, but we also have some of our personal endpoints also have presence capabilities. Federation based on XMPP is the way we picked, and I think it's the most flexible way or most scalable way to increase your presence functionality. So we are currently working with other companies active in the presence space like Microsoft and IBM to make sure that we can federate with them. A wonderful way to scale your system if you don't have enough resources and bandwidth is streaming. Why is streaming so good for scaling? Mostly because the computing power in the streaming server is much lower than the computing power in the multi-point conferencing unit. And the reason for that is there's no real-time requirement. You can stream with a delay. You can use much larger jitter buffer in the receiving device. For example, when we do a video call here, a real-time call, our jitter buffers are set at 40 to 60 milliseconds. Maybe 80 milliseconds, that's the maximum that you can, actually 40 to 60 is probably much more realistic. When you do streaming, you can set your buffer to be seconds, several seconds, doesn't matter because you don't have the real-time requirement. Right now, most of the streaming is done to PCs and Macs, but it is possible to do streaming to video endpoints if the bandwidth is an issue. Video phones, mobile phones, set-top boxes, all of these devices are candidates for streaming, receiving streaming content, and that's probably something that Fabio likes a lot if he's still here. So recording can be done from a single presenter, basically calling the streaming server and recording, pressing the recording key. Point-to-point calls can be recorded as well, or multi-point calls can be recorded as well. All of the information is stored here. The streaming can happen simultaneously or can be done later, whenever the user connects to the streaming server and starts looking at the stream. Another way that to have scalability is to move the file from the recording server to a special purpose server for content management. These servers tend to have multicast support and support thousands and thousands of users. So you can really have a video on demand kind of experience, even put it on the internet and have pretty much everybody look at this content. We find that very useful for promotional materials. Companies buy that to make sure that their marketing materials and recordings go out. So this is a very good solution. From a security perspective, also, it's possible to split it and have certain access from the internals, from the inside the network, so that employees can look at certain content, and then you can have another subset of the content that people from the outside can see, and I think that's very important. Okay. I talked about IT integration, and the most important issue today, from our perspective with IT integration, is integrating with directories. That is something that Internet 2 is discussing a lot. It's a big issue in enterprises as well. Most of the organizations we work with already have some kind of a directory. Sometimes the access is web-based, but in many cases it's, especially in the enterprise environment, it is Microsoft Access Directory. So the good thing is that all of the directories on the market support LDAP in some shape or form, the Lightweight Directory Access Protocol. So there are two ways to access it. You can have the endpoint go over LDAP and retrieve information, and the information is usually contact information. I send the name and I get phone numbers and emails and all the other IDs related to this person. Or the endpoint goes to the server and the server does the lookup. This method, going through the server, is actually more scalable because LDAP is not designed to do fast updates. So if you do this, you will overload the server very quickly, and your IT department is going to kill you, basically. So if you do it through the server, you can cache content here. You can download the information, or you can do one lookup in the morning, and then you can use it for the entire day, and next day you can do another lookup. And that's something that the IT departments are much more comfortable with. For people who have the older video endpoints that use a global address book or any other kind of phone book that is downloaded to the video endpoint, also the solution that is using an intermediate server is a good solution, because you can use LDAP and the H350 extension to retrieve the information, and then it can be accessed from newer endpoints through the LDAP or from older endpoints through the traditional GAP protocol, and the conversion between the two happens in here. And this is an approach we have right now because we have to keep our existing customer base happy. So this is the approach that we're using right now to solve this problem. I'm not going to talk about calendaring much. This is very similar to scheduling. The only difference is that you integrate with calendaring applications like Microsoft Exchange or IBM Same Time, or actually Lotus is the calendaring application. The one thing that we did here to increase scalability is, in the past, we would have the calendaring application in here, in the MCU itself. Now we put it on a separate server, on the management server, and this way we can scale and support many more conferences. We can allow universities to plan, for example, 1 year ahead. They can plot their video calls 2 semesters ahead and store all the information in the server, and when times is right, the server will tell the MCU to call everybody who is supposed to be on the call and connect them all in a call. And at the last conference in Bruges, this is my last point and I'm finished, there were several people who asked me about large room deployments. How do you do that? How do you equip a large room, like a conference room, auditorium, classroom, or concert hall with audio and video? So the video component is clear. You put multiple large screens, and you can resolve this problem, especially if you have high definition video quality. People will be able to see that. Maybe for this environment, I would recommend going with 1080p quality, because it's going to be blown up on a big screen. However, the audio is a problem. So we have a solution because of our background in audio. We have a solution that's currently called Sound Structure. The previous generation of the product was called Vortex. And it's really a giant farm of DSPs doing more or less echo cancellation. The main function is echo cancellation. And what you can do is you can connect up to 16 speakers to this box, up to 16 microphones, and spread them across the room. And the room can be big. It's usually used in concert halls, in churches, big rooms where there's a lot of echo, big spaces where you have a lot of echo. So it does the echo cancellation, but even more than that, it does also noise reduction, equalization of microphones and speakers, and a bunch of other functions that really adapts to the environment. Now, the beauty of this box is actually that it connects digitally to a video endpoint. So the biggest problem when you do that and don't have a direct integration is that this echo canceller will work against the echo canceller in this box. When you do mute here, the mute here will not be activated. So you have to have a digital link between the two that synchronizes this functionality. And that's exactly what we did. Another component is really to make sure that all the frequencies get canceled, starting from something like 20 hertz up to the 22 kilohertz. That's what we call full band. And stereo is important, and auto discovery is important because you don't want to do any configuration. You just want to plug them together, and they start working as one thing. And shared mute and volume buttons are very important as well. This is something we're using with organizations like the Manhattan School of Music when they have their performances in big concert halls. That's how they connect to remote sites. They have a video call with a bunch of monitors connected here, and then they use the sound structure to do the audio in a big room. And that's the end of my presentation. The takeaway is the scalability is a very complex topic. You cannot do scalability in one part of the network and forget the other because it has to be, everything in the network has to be scalable. There are several components that can create bottlenecks, and I explained that in the presentation. And our core competence and our focus right now is really to figure out how to overcome these bottlenecks and make sure that the networks that had several hundreds of conference rooms yesterday can grow and support 10,000s and hundreds of thousands of users tomorrow, because desktop video is really about hundreds of thousands of users on a single system, and we have to figure out a way to do it. This is my contact information, and there's a white paper around this subject. It's called Scalability, or Managing, Building a Scalable Video Network, or something like that you can download from this webpage, and I'm open to hear your questions. Thank you so much.
Questions?
Wow, I must have been very clear.
Yeah.
Okay.
Okay, so thank you very much.
Thank you.
The next session in the same room, I will be the chair for the next session in the same room. The keywords for that session is e-learning, objects, metadata, video, mainly music, transmission over IP. So I'd like to welcome you back after the break. Thank you very much for your participation.